Welcome back to the SD online classes. In this class, we will do electric power of a device. It is the rate at which any of the device that we are concerned with is consuming electrical energy. Okay, that means how fast it consumes energy, that much. In simple, electric power is if a device is there and it is taking a lot of energy very fast, that means it is very powerful, that means the power is high. If there is one device which takes electrical energy it requires, but it takes it very slowly, that means its power is less. That is the understanding of power concept. Now to write this understanding into a formula, how we do is we say that it says the work done per second by the electric current flowing through a conductor. Suppose that current is I, I'll assume it is I, and the potential difference on that device is V across it. Then the electric power will be P equal to work done per unit time. How fast it is doing work, consuming energy is it's doing work, and compared with the time is per unit time. So now you know that work done is nothing but it is the electrical energy consumed. So in place of this we will write electrical energy. Okay, we will write electrical energy. That means their units are same, you know that both are joule. So electrical energy is nothing but that work done and the time it has taken in consuming that electrical energy. So symbolically I can write P is equal to W by T. This is the expression for power. Now after this, merely what you will do is very simple, only the unit conversion, the change in this symbol W by other things, like P is equal to W by T can be written as V I T by T. Why? Because since W is equal to V I, okay, work done is V Q. Work done is potential difference into charge, and then charge you already know, in the previous derivation also we did, current into time. So this is W is equal to VIT. So in place of W I wrote VIT. Now T and T will cancel out, so you will be remained with VI. This is very easy to remember. Power is nothing but VI. In terms of potential difference in current it is VI. In terms of work done and time it is W by T. Similarly we can also write in terms of other factors, P can also be written as, in place of V, if I replace it by IR into I, that means here what I did, since V is equal to IR, then it became P equal to I into I square into R. Okay, so this is P is equal to I square R, P is equal to VI, done. Similarly we can also write P in place with the help of V and R only. So what you will do is V into here V by R. What I did here, since I is equal to V by R, how I am changing this is nothing but Ohm's law only. Okay, Ohm's law is allowing me to write this. So what I get finally here, P is equal to, P will give me what, V into V square by R. So this way we get several expressions, many expressions of the same thing, power. P can be written as W by T, work done by time. P can be written as potential difference into current. P can be written as I square, current square, and resistance. P can be written as potential difference square by resistance. Okay, so these are the expressions you can use in your numericals. Okay, so this is about power. Further, you see SI unit of electrical power, not just power. Okay, electrical power, because power is defined in other physical things also. So here specifically what we are studying is electrical power, but its unit is same, watt. W is the symbol for that. Okay, how much is 1 watt? You can understand 1 watt from the formula only we are getting it is 1 volt. How I got, I'll tell you, into 1 ampere. How I am getting this? Because you know that the power was equal to V into I. If you remember, one of the expression was P is equal to VI. So when this is 1 watt, V 1 volt, I 1 ampere. So this is helping me to define what is 1 watt. 1 watt is that power which is given by your 1 volt and 1 ampere. Okay, that will be called 1 watt. So on behalf of this, what I'll write, 1 watt is equal to 1 joule per 1 second. Okay, so this is the one. So here we can write W is nothing but joule per second. W, watt, is also called joule per second. Okay, there are other bigger units of power. What is that? Kilowatt, K small letter. Kilowatt is 1000 watt, which is otherwise 10 to power 3 watt. Then 1 megawatt, capital M. This will be 1, 2, 3, 4, 5, 6 watt. Okay, this will be 10 to power 6 watt. 1 horsepower, this is important. In some numericals it asks 746 watt. Okay, you remember this conversion. Mega is 6 zeros, kilo is 3 zeros. Okay, this is how power's SI unit is written. Now power rating in India, domestic voltage supplied is 220 volt. Everywhere it will be 220 supplied to the homes. Domestic means homes, but different devices will have different power ratings. Like some bulbs will be 60 watt, some of your other devices 100 watt, some will be 200, like your television 400 watt, fridge will be some other watt, like that. All the things will have their own watt, W. So that will, what is the meaning? The meaning is that how fast or how slow they consume, they eat that electrical energy supplied to them, that will be told by the power. If the power is high, that means if you run it for 1 hour, it will consume lot of energy. If the power is rating is low, that means even in 1 hour, 2 hour, it will consume very less energy. So you have to give less money for that. Okay, that is the understanding of power rating on a device. Okay, now this topic, power dissipation due to current, is what? Simple example. Here suppose there is one device, okay, and it is used for long time. Okay, used for long hour. Then what you will find is current will increase heat. Okay, so this is unwanted heat. So device gets heated, which is not desirable, Okay, this is called dissipation of energy. This energy is spent in the form of heat, which is not useful. Suppose you want to use your fan, example, you are using a fan for some hour and the heat is wasting electrical energy. It had to convert the electrical into mechanical energy in rotating, but some energy of the electrical part is converted into heat and it is wasted in the environment. So this is called dissipation of due to current. And sometimes in some of the device, what will happen, current passes for long time, current passing for long time causes change in properties of the material. That material's property starts changing due to that long time of current passing due to heat. For example, we are measuring current with the ohms pin, that the indicator, okay, and after some time that nichrome wire, the current passing from the nichrome wire for long time, then what happens that it gets heated and the reading gets different because of that long time current passing through it, which is making extra current. Now we try to understand what is electrical energy. Okay, power is okay, but energy is why needed, because the charge that you use, the electrical energy that you use, and you have to pay the bill, all this is because of the energy, how much you spend it, okay, not the power. The work done or energy liberated, used up or consumed by the electrical appliances like devices during its operation is called electrical energy, how much you have used. So how to find? Power is work done by time, work done is that energy, remember, so E by T, E is the energy used, T. Now you cross multiply, P into T is equal to E, the energy is power into time. Okay, so this energy is important because this is what we calculate in our electrical bills and everything. So this will be joule, this will be watt, this will be time. So in the unit also I'll not rewrite it, it is electrical energy's unit is joule, power is watt, T is time. Okay, now we shall convert a very common unit in the electrical energy. 1 kilowatt hour is the common usage in our bills. 1000 is this, kilowatt is 1000 watt, 1 hour is 1 hour. Now I'll convert this 1000 watt into 1 hour, you remember it is 36 into 60 into 60 seconds. So altogether it will become 360012 3456 23456 watt second. Okay, this much is the energy. In short, I'll write 3.6 into 10 to power 6. I can write watt second. How I'll write this? I can write it as joule. It is the energy unit W. Watt second and joule is same. Okay, so 1 kilowatt is this much. This 1 kilowatt is 3.6 into 10 to power 6 joule of energy. Okay, this is all in our chapter 3. Now the rest will be followed by this.